Hello everybody, welcome back to my channel, and today I'm going to start my electrical part 2, and today I will deal with these three questions. That is very important questions: synchronous condenser working and how it's work as a under excited, how it's work as a over excited, what is under excited, what is over excited. So I will explain each and everything. Stay tuned in our video, and after that I will go for what is the feeder panel, group starter panel, and what is the actual difference between the feeder panel and the group starter panel. In our vessels also there are so many feeder panels, one feeder panel, two group starter panel, what is the group starter panel. And after that I will go for the what is voltage doubler circuit, triplet circuit, and working of it. So stay tuned in our video. So let's start the video. So guys, what is synchronous condenser? So synchronous condenser is basically we are using for improving the power factor. I already explained in the first part of my electrical lecture what is power factor, what is active power, what is reactive power. Everything I explained in my first part video. So if you not watched my first part video, so please watch. Otherwise I will explain here also little bit for better understanding. So let's go. Synchronous condenser basically what a synchronous motor which is directly connected to the bus bar. You can see here, which is directly connected to the bus bar. Here this is our bus bar, and it's directly connected. With the bus bar, and this is the shaft of the motor which is not connected anywhere because it's running but without any load. We are not giving any load here. So it's running without a load. So active power exchange is 0. Why active power exchange is 0? Because we are not taking this power in any mechanical means, because this is a mechanical power generated from the motor, but we are not connected anywhere like pump and anything. We are running it without any load. Okay, so this is no load connected, so here no active power exchange is there. And reactive power here only we are exchanging because it's connected directly to the bus bar. So we are here exchanging the only reactive power. So first of all I will just explain you little bit what is active power and what is reactive power, apparent power. So active power is the power needed to do the useful job. It means the power which generated by the motor in a mechanical means, we are consuming it in another means, like we are running the pump, we directly connected with the pump with a coupling, and we are taking this power to run the pump and all this. So we are taking this power as a active power. Okay, so active power, the power needed to do the useful job, denoted by the power P. It's generally denoted by power P. Okay, so then after that I will tell about the reactive power. Reactive power, they don't do any useful work. It means the reactive power, they don't do any useful work, but it is very important because if no reactive power, no active power will exist. Okay, why? Because I will tell you the power which is not useful, does not do any job, but support to maintain the magnetic field throughout the circuit. It's always maintain the magnetic field throughout the circuit, because let's suppose you give the active power but without any magnetic field, how you can turn the motor, how you can generate the power and all. So for torque, if you need any torque to rotate a motor, you need reactive power because it's create a magnetic field and support the magnetic field throughout the circuit. Okay, and without, if no magnetic field will there, then there is no interaction between the magnetic field of the rotor and stator. So no current will induce, no EMF will induce, and no torque will produce. So this is very important, because if there is no reactive power, no active power will be there. So okay, you understand active power and reactive power. For better understanding I will explain in the part 1 lecture, so you can watch there also. And what is apparent power? What is apparent power? Apparent power is the vector sum of active power and reactive power. If you do the vector sum of this, as denoted by S, apparent power, it is the vector sum denoted by S. So you will get the apparent power with the help of reactive power and active power. Okay, so now I will just explain how it's working as under excited and over excited. Basically the main purpose of this synchronous condenser is to improve the power factor, because let's suppose you are connected so many loads to the bus bar and suddenly the voltage drop to a very minimum voltage, and after that your motor efficiency will decrease, your pump capacity will decrease, it will not get the accurate pressure, it will not you will see your ampere will be very less. If you want the more ampere from the motor will give very less ampere, because too much load is connected, so power factor will decrease. What will happen? Power factor will, cos phi will decrease if there is too much load. So what you have to do, you have to increase the power factor. How you can increase the factor? You have to run this synchronous motor in overexcited mode. If you run this synchronous motor in overexcited mode, your power factor will be improved, because at that time this synchronous condenser will act as a capacitor. Because you know the behavior of capacitor will lead the current. Actually in capacitor, current will lead by voltage by some angle, and it will start delivering the reactive power to the bus bar. So in the overexcited mode, you have to run this synchronous condenser in overexcited mode, so that it will start sending the reactive power to the bus bar, so that our cos phi will improve. So you understand? So I will tell you very easily. Wait, I will take this stroke eraser. Okay. Now I will explain. You see here, if let's suppose, but how you can run this overexcited and underexcited? Here is the case. EB is our back EMF. Okay, back EMF. But you know the working of the synchronous condenser. If you don't know the working of the synchronous condenser, so I will explain in another video, but here you just remember, I will tell you something. In the synchronous motor, what we are doing now, we give stator, this is a motor, we are giving three-phase supply to the stator. We give three-phase supply to this stator, three-phase supply, we are giving three-phase supply to the stator. But at the rotor we are giving DC supply. Here we are not giving any supply, because in induction motor what will happen? Due to this three-phase supply, there is a relative motion between the stator and rotor. So due to this relative motion, the induction motor start rotating, and that is called slip. But in the synchronous motor, we are not giving the DC, we are not giving any supply in the synchronous motor, we are giving the three-phase supply to our stator, and here no any flux generate at the rotor, because we are giving the DC supply at the rotor side for the field excitation. Okay, we are giving here DC supply, and after that we have to run this synchronous motor by any external means like pony motor, by the help of damper winding, so that it motor will start working as a synchronous. There is no relative motion between the stator magnetic field and rotor magnetic field. Okay, so I will explain each and everything in a separate video of the synchronous motor, so you can understand it very well. So better you just remember we are giving here the DC supply at the rotor, and we are giving the three-phase supply at the stator. So if we increase this DC excitation, so that our back EMF will increase. Back EMF is the external magnetic flux which is produced by the help of the rotor. Okay, so if you give this DC excitation, our back EMF will increase. So again, if you give more and more excitation, so back EMF will more and more increasing. So at a time come when your back EMF is greater than the busbar voltage. Okay, it's greater than the busbar voltage. So at that time it will act as a overexcited. What happen? It will act as a overexcited. Now what will happen? It will start sending reactive power to the bus bar to improve the cos phi. You understand very well? So what we are doing here? We just increase the DC excitation. We just increase this DC excitation, so that our back EMF will start increasing, and at a time come when this back EMF will our back EMF will greater than this busbar voltage, so it will start working as a overexcited and start sending the reactive power. It means it acts as a capacitor. That time it acts as a capacitor. Okay, and when our back EMF is less than busbar voltage, let's suppose our busbar voltage is 440 volt, but our back EMF is not greater than this, So that time it act as a under excited synchronous motor. That time it act as a under excited synchronous motor. Okay, so start drawing the reactive power that time, and act as a inductor, because you know inductor lacks a current by some angle by voltage. So it acts as an inductor and start drawing the reactive power from the bus bar. That is a motoring effect in the generator also sometime. Okay, so here you will tell why it is beneficial to draw the reactive power. So this is also you can tell like this, because let's suppose your generator is connected with a very minimum load. When the load is very less, then cos phi will become very high, then your power factor will improve already, because your load is no because very less load is connected to your generator and bus bar. So that time your power factor is already improved, and it is increasing like this. But we have to maintain our power factor throughout the system. So that time we run this synchronous condenser as in under excited mode, so that it will start drawing reactive power and maintain the power factor throughout the circuit. That time it will act as an inductor, because it will draw the reactive power to maintain the power factor. Okay, to maintain the power factor. So surveyor will ask you also this question like this. So now I think you can understand this very well. Okay, so if it acts as an inductor, that time current lag by V, and if it act as a capacitor, that time I lead by V. You can read this in 12th also. This is the 12th concept, inductor, capacitor and resistor. In the resistor, voltage and current is in same phase. Okay, voltage and current is in same phase. That time the circuit act as a resistor. And when in inductor, current lag by V with some angle, and in capacitor, current lead by V by some angle. So you understand this very well, ki how the synchronous condenser improve our factor, improve our power factor, why it is necessary, and what is under excited, what is over excited. I think your concept will be cleared. Okay, so this is the synchronous condenser. I think hope you understand this concept. If you have any doubt, you can ping in the comment section. I will clear your doubt. Okay, so I will next forward to the next question. This is our next question. What is the feeder panel and group starter panel, and what is the actual difference of it? I will just tell, because one time this surveyor asked this question to me also that time, and explained so many things. Let's start the number 2. Okay, what is feeder panel and group starter panel? Okay, you know the alternator produces electricity which is then going to the engine control room, but how it's going to the cables and wire. Okay, I will explain you with the help of the picture. Okay, this is the picture. Let's suppose this is our diesel engine, and here is the alternator side. You see generator in your vessels, that is big capacity vessel is there. I just take the 440 volt generator example. So here you see this R phase, Y phase and B phase. This is the 3 phase which are taking output from the alternator. Okay, so this is from this the diesel engine and alternator, because this is the alternator side, we are taking the power output, 3 phase power output, and with the help of cables, these are the cables, these are high insulation cables which are connected from the alternator, and it's provide power to the another circuit. But how it's providing, I will just explain. What is feeder panel and then what is group starter panel, you will explain very easily to the surveyor. So this is the cable which is drawing power from the generator, and it's going to the bus bar. Okay, it's going to the first bus bar, and after that it bus bar connected to the feeder panel 1, feeder panel 2. This is the feeder panel 2, and same power is going here, that is feeder panel 2. In the engine control console, you will go and see there is a section, port side and starboard side. In the port side, like in the port side and starboard side, there is a feeder panel is there. If you notice, there will be written the feeder panel 1 and feeder panel 2. Okay, always right, but that is for 440 volt and 110 volt. 110 volt we are using in a small lighting equipment, navigation light equipments and all. So power is distributed via the bus bar with the help of bus bar, but in the low voltage side 110 volt or maybe 220 volt also sometime in the vessels. In our ships generally 220 now available. So how we can convert 220 from 440? Because this is the 440 side, we take one transformer, air cooled transformer, and after that we convert this from the 440 volt to 220 volts, so or 110 volt. So it will give the feeder panel 1 power supply, and after that 440 is connected with the bus bar, and bus bar delivering power to the feeder panel 1. Okay, feeder panel 1. And after that this power here also providing the starboard side feeder panel 2 and the low voltage side 110 volt feeder panel 2. So how the power is distributed? It coming from the generator via the cable, going to the bus bar, and then going to the feeder panel. And same as the port side also and starboard side also. And low voltage we are using the transformer to convert the voltage in the low voltage, then giving to the feeder panel. Okay, so how it's working now you understand. And but what the things are connected with the feeder panel? So I will explain you. In the feeder panel, like the example 440 volt, there are so many power distribution panels are connected, because power is now distributed from the feeder panel to the low to the other motor machineries, and other panel is there. Always you will see in the engine room the other panel, P1 panel, power panel, P2 panel is there. It means the power is going from this feeder panel to different location via the panels. Okay, there are the various places in the vessel you will see different panels. Okay, P1 panel, P2 panel, L1 panel, L2 panel. So how it's getting the power? It's getting power from the feeder panel. Okay, and these are the small panels which is getting power from the feeder panel. So feeder panel is providing the power to the small panels, and also providing the power to the group starter panels, and group starter panels is taking power from the feeder panel. So feeder panel is a feed of a power from bus bar. Its power is coming to the feeder panel, and power is distributed to the small panel and the group starter panel. So now you can understand it very well. What is group starter panel? Group starter panel is taking power from feeder panel. Okay, power from feeder panel. And with the in the group starter panel, what happened? There are the several motor starter is there in the group starter panel, like small motor also there, big motor also there. There are so many starters in the group starter panel for starting or stopping the motors. Okay, so it's get power from the feeder panel. There is also power distribution panel which is getting power from feeder panel. P1, P2, P3, P4, P6, motor panels, crane, provision, AC, all are getting power from this feeder panel. Okay, and this 110 volt AC is also having the different panels. It's going power, navigation panels, all lighting panels. Okay, engine control console, bridge control console, ballast control, fire alarms, and other power distribution panel also getting power from this low voltage power side feeder panel. Okay, so now you understand what is the feeder panel and what is group starter panel. So you will explain very easily to the surveyor also, in exams also, if somebody asks you. Okay, so I think hope you understand this concept. Let goes to the another question. If you have any doubt you can ask. Okay, no problem. So here you can see also, here I will just explain a little bit. Okay, you see the alternator produces electricity, which is then goes to the engine control console to a bunch of wire beneath of the ECR, and these wires then led to a rectangular bus bar at the back of the panel known as the bus bar. The main advantage of this bus bar over the cable is that it can easily connect a motor starter panel and other kind of load. Okay, so feeder panel is there, 1, feeder panel 2 is there, feeder panel 1 low voltage, feeder panel 2 high voltage, also giving power to the generator 1, 2, 3, that is air circuit breaker is connected there, and synchronizing panel also, and now connected with the group starter, earth monitoring, distribution board. Okay, so you understand this. Let's go to the voltage doubler circuit. So What is voltage doubler circuit? Voltage doubler circuit is an electronic circuit because it is a just electronic circuit that produces an output voltage that is double the input voltage. Let's suppose we are giving AC voltage at the input. If we are giving the AC voltage at the input, in output you will get the of 2 times of the AC voltage, but in the DC form, 2 times of AC voltage in DC form. Okay, DC form. So what here we are doing, we are just amplify the voltage by 2 times, but how we are doing, just now I will explain. Okay, 2 times. And the voltage tripler circuit is what, we will triples the voltage 3 times the voltage will 3 times input voltage equal to output voltage. Okay, output voltage 3 times we are getting. So voltage doubler circuit is an electronic circuit that produces an output voltage that is double the input voltage. It is a voltage multiplier with a voltage multiplication factor equal to 2. Okay, the circuit is formed by oscillating AC input voltage. Here at the input we are taking the AC input, and with the help of 2 capacitor and 2 diode, we are just multiplying the voltage by the 2, because we are using here 2 capacitor and 2 diode. By increasing the 2 capacitor and 2 diode to 3 capacitor and 3 diode, we will get 3 times of input voltage. Okay, so you understand the triplet circuit also. The input voltage is AC, output is DC voltage with twice the peak value of the AC input voltage. So how it works, so I will just explain. And what is the advantage? Actually there are 2 type of main voltage doubler. Half wave voltage doubler is there and full wave voltage doubler is there. Okay, so an advantage of voltage doubler is what, it can replace the expensive and heavy transformer, like you are using the transformer for step up the voltage, step down the voltage, like this we are using. So in step up condition we are just amplified this voltage with the help of the voltage doubler circuit. So power will multiplied and amplified very easily. We don't need any big transformer like this. So negative voltage can also be created by reversing the polarity of the connected diodes, and so you can generate the negative voltage also, it means step down voltage also, with the help of reversing, just reverse the polarity of diode and capacitor. So it can also possible. Can increase the voltage multiplication factor by a cascading the similar voltage multiplier. Okay, so how you can increase the voltage multiplication, we can increase the multiplication factor 2, 3 like this also by cascading the similar voltage multiplier. Okay, we are using in X-ray system, television system, ion pumps, copy machine, radar equipment, traveling wave tubes, etc. So these are the examples. So how it's work, now you understand very well. We are taking here AC signal, this is the voltage multiplier circuit, and we are getting the DC 2 times of the AC input voltage. Okay, so how it's working, this is the circuit, you can see here, this is the circuit, this is the D1 diode, D2 diode, and this is the C2 capacitor and C1 capacitor. Here we are giving the AC input. Okay, so we are getting here output 2 times of the peak voltage of AC input voltage, Okay, so how it's working, let's understand. So let's suppose we are giving the AC cycle, and this is the positive and negative, 2 half is there. So positive half cycle, what will happen, D1 will act as a forward bias, because the positive, now positive will, I will explain, because now here positive will go here. Okay, positive will go here, so it will act as a reverse bias, and it will act as a, because positive is connected with the positive side and the negative is connected to the negative side. Okay, so what will happen, this is forward bias, so diode D1 is forward bias, and now C1 will charged by a potential of V, V max of AC input. Okay, so here what will happen, it will charge the potential by the Vm, and at the at the charge with the Vm, and for the negative half cycle what will happen, you see here negative half cycle, for negative half cycle if you give here negative and here is positive, for negative here negative, positive, and here negative, here positive. Okay, so This will act as a forward bias now, and this will act as a reverse bias now. So D1 will reverse bias now, and D2 will forward bias. And at the time of negative cycle, D2 charge capacitor C2, D2 charge capacitor C2 by a potential and voltage up to Vm, maximum peak voltage of AC input. So resultant you are getting what? 2 times of voltage, 2 times of voltage. Okay, take potential Vm plus Vm, and total potential in a complete AC cycle we are getting 2 times of AC input voltage in a DC form, because diode will convert this AC into the DC voltage. Okay, so now waveform will look like this. This is the output waveform, so you understand it very well. And full voltage doubler is just we are interchanging the connections of capacitor and diode and positions, and here we are giving this AC input, this voltage doubler circuit, and same principle, you give positive negative like this, and after that you will get 2 times of voltage maximum with the help of this circuit. Okay, so I think you understand this concept, this full voltage doubler circuit and half voltage doubler circuit. So you just read through this. This is the concept totally. I hope I explain each and everything very easy way. If you understand this video, please like our video. Hope I will meet soon. So next electrical part 3 will come soon. So you just enjoy our video and read this video and share as much as possible, please guys. This is very hard work, because I am doing very hard work for you guys for understand the concept in a very easy manner. So I will not tell anything. If you like this video, please like this video, subscribe my channel, and share as much as possible, because most of the guys will get benefit from this video. So hope I will meet soon. Stay tuned in our video. Thank you very much.